Hey Math Marvels, welcome back. This is lesson 101. We're going to find products and quotients in scientific notation. In the last lesson, we learned how to add and subtract, and it was a lot of work because we needed the exponents by 10. They had to be the same. That's not going to be the same for multiplying and dividing. In this situation, we're going to multiply and divide the multipliers when finding the product quotient. So that first number, we're going to either multiply or divide them. And then we're going to use our product and quotient rules for exponents in order to multiply or divide our exponent numbers, our 10 to the nth power. And we'll use this information to solve real-world problems that require multiplying and dividing numbers in scientific notation. Let's look at our first problem. Now that we're doing multiplying and dividing with scientific notation, I want to make a huge distinction between adding and subtracting and multiplying and dividing. For multiplying and dividing, the exponents don't have to change. They do not have to be the same. So let's go back a little bit and think about our product rules and our exponent rules, just as a very quick review since it's been a little while. Remember, with the product rule, we had two numbers be multiplied as long as it was the same base in front and our exponents were on the side, and all we did was add them together, a plus n. So think about it in the context of what we're doing today. We're going to have numbers in scientific notation. So we're going to see a number like, I'm going to use a b. b times 10 to the 5th times c times 10 to the 6th. So our bases are the same. And because our bases are the same, all we have to do is add those two together to get our new product. So what's going to happen with these two numbers in front, our b and our c? They are also going to be multiplied together. Okay, and we do not have to make a change. Multiplying and dividing is actually a lot easier than adding and subtracting. The same is going to be true for our quotient rule. So imagine we have am divided by an. In this case, we're subtracting. And so the same would be true here. So if I had b times 10 to the 5th divided by c times 10 to the 4th, again, our bases are the same. So I'm just going to subtract 5 minus 4 to get 10 to the first power. And my two numbers, I am going to divide them, b divided by c times 10 to the first power. So that's going to be our goal. It doesn't matter which one. We don't have to make a change. We're just going to use these two rules. So let's go back to this problem. And I'm just going to use my order of operations. And that means I'm going to do my division first. 4.8 divided by 1.2 times 10 to the third and times 10 to the second. So I'm just going to rewrite this, and I pretty much know I have 4.8 divided by 1.2 times, and in this case, I'm just doing 3 minus 2, which is just going to give me 10 to the first power. That's it. Let's complete that division part. 4.8 divided by 2 is just 4. So I have 4 times 10 to the first power. Let's go to the next phase. And now I'm multiplying this by 2 and 2/10 times 10 to the negative 4th. So again, I'm going to separate these. So these two terms are being multiplied, and these two terms are being multiplied. So 4 times 2.2, that's just 8.8 times, and you're going to do 1 plus negative 4. So 1 plus negative 4 is negative 3. So here is your final answer, 8 8/10 times 10 to the negative 3. And that's it, Math Marbles. That's the major takeaway. You don't have to change the exponents, but you do need to know and remember your product and quotient rules for exponents. Hit pause and jot this down into your notes. Let's look at our second problem together, and this time it's a word problem, so we're going to have to do some thinking. We're either going to multiply or divide. Kevin moved from a city to a small town. The population of the city is 3 times 10 to the 5th, which is 15 times as great as the small town. What is the population of the small town? Okay, so given there are a lot of hotspots here, we have a 50-50 chance if you were to guess, and we don't want to go into the guessing mode. But what do we know? We know that the city has a population of 3 times 10 to the 5th, and we know that that is 15 times greater than the town. So given that, if I want to find the population of the town, I'm going to divide both by 15. That will give me the population of the town. Okay, notice in this case I don't have another number written times 10. I don't have 15 times 10 to the something power. That's not there. Could you write it and just make it times 10 to the 0 power? You could, but it's a little bit unnecessary at this point in time. So watch what I'm going to do. I'm going to divide 3 times 15, and that's going to give me 0.2. So now I have 0.2 times 10 to the 5th. However, it is not written in scientific notation, so I need to make a shift. I need the decimal to be behind the 2. So in order for that to happen, for this number to get 10 times bigger, that means my other digit needs to be 10 times smaller. So one shift, that means my exponent is going to decrease by 1. And now I have the population of the small town. Hit pause and jot this one down into your notes as well. So again, Math Marbles, major takeaway when we're working on word problems, we may be doing multiplying or dividing. Sometimes the numbers are written in scientific notation and sometimes they are not. For those who wanted to ask a question like, well, what would happen? Would that make a change if I had written 15 in scientific notation? Well, let's take a look. If I had 3 times 10 to the 5th over 15, I just wanted times 1, so 10 to the 0, there would be no change. The 0 is still just 5. So that would matter, and I would still do 3 divided by 15. So again, no change. That's it for today, Math Marbles. Get some practice in, and please remember to review your product and quotient rules if you find you're making small computational errors. And I will see you in the next lesson. Be well.